All right. Good afternoon. Today we are going to talk about something called end behavior. So end behavior is just kind of like if you were to read a book. Like I know this isn't a book, but there's pages inside. Can't see pages inside, but it's kind of like reading the front cover and the back cover. Okay, so what happens on the left? What happens on the right? That's what we call end behavior. What happens on the ends? And so we call this a parabola. It looks just like x squared. And so if someone were to ask me, I would say on the left side, it opens up. And then on the right side, it opens up. Okay. And so we would say it rises on the right, rises on the left. Now this is probably the confusing part. The way you read this is about left and right. So right here, this is another way of saying to the right. I'll make that a little bit bigger. So this is like saying as you go to the right. That's all that means. So as x approaches infinity, what happens? So as you go to the right. Now this notation right here just means as you go to the left. So this is left side, and this is right side. Ooh. And then positive infinity, that's the way of saying it goes up. Goes up, which it does. On the right side, it goes up. But on the left side, it also goes up. Okay. Whereas here, on the right, it goes down. On the left, it goes down. See, right it goes down, left it goes down. On this one, and notice x to the third is, anytime you have an odd exponent, you're going to have opposite end behaviors. Hope you like my finger puppets today. But, well, I don't have puppets, but anytime you have odd, they're going to do opposites. Okay, so you're either going to have down and up or up and down. But notice, the way I would read this is as you go to the right side, we'll do this one. That'd be right side. On the right side, it goes up. That's why you put positive infinity. On the left side, it goes down. That's what negative infinity means. And notice that it in fact goes down here and it goes up there. Okay, so that's all end behavior is. And notice we call this the graph comparison. Some people might call that the parent function. Now, turning point. So what do we call a turning point? A turning point, if I draw a quick graph, so we're going down, we're going down, we're going down, and then we would call this a turning point where it starts going back up. It's going up, and then as soon as it starts going back down, it's a turning point. Back up is a turning point. Back down is a turning point. So we call turning points would be here, 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 and here. And there's a theorem that says if you have degree of n, okay, and we'll talk about what degree means. It just means the highest exponent. Then it doesn't mean it has that many number of turning points. It just means the maximum number of turning points is that degree minus 1. So if the degree is 7, maximum number of turning points would be 6. Now we have something called multiplicity. And really the big thing to get here is if you have odd multiplicity, like 1, 3, 5, 7, it goes through the graph. And if you have even multiplicity, it touches the x-axis but doesn't cross it. So here's an example of an even multiplicity. So what do I mean by even? That'd be 2, 4, 6, 8. What do I mean by odd? 1, 3, 5, 7. But normally, just so you guys are aware, if it's like 3, 5, or 7, it usually looks like this when it crosses. So that's usually a good way to show. Some people call that a squiggle, But if it goes 3, you know it's odd multiplicity. They called it a U-turn. I guess that's a good example. So let's look, okay? I may not do all of this all at once, but so the leading coefficient, you have to look at the one that's the highest exponent. So this is 7, so we're going to be referencing this term. This one has the highest exponent of 6, so we're going to reference that term. This has the highest exponent of 5, so we're going to reference this term. They're not always written in order. So what is the leading coefficient? That would be the number in front. So here I'd say 4. Here I'd say -7. And here I'd say -2. Okay. Now what's the degree? The degree is the exponent. Probably do a little bit better color. So 7. Forgot a 6 or 8 is probably better. So here I'd say 7. That's the exponent. So I write 7. What's the exponent? 6. What's the exponent? 5. Now, graph comparison. You're going to compare that to x to the 7th. You're going to compare that to x to the 6th. Or you could say -x to the 6th. I don't really like the graph comparison part. I don't think it's really worth it. And then here, -x to the 5th. All right, what is the end behavior? You could, in fact, go type this into Desmos. You could. I'm going to show you a better way. The leading coefficient, if it's positive, like 4, that means it opens up on the right side. It opens up. When it's negative, it opens down on the right. Negative opens down on the right. And then from there, this is how I do it. So I look at this number, and if it's positive, I know it opens up on the right. If it's negative, it opens down on the right. Now, if you have an odd degree, it's going to do the opposite on the left. If it hasn't, so if that went up, that one goes down. If it's an even degree, it does whatever it does on this side, it does on this side, because evens always repeat themselves. Okay. So even if this went down, that has to go down. If it had gone up, it'd go up. This is odd, so if this went down, the other side must go up. And now we're going to write that out. So I would say as x goes to the left, as x goes to the left, what happens? The function, we'll call it f of x. They're all called f of x. F of x. And by the way, I have a 10 key on my computer. I don't think you have a 10 key. That's how I'm able to do this super fast. Feel free to draw these if you would like. So as we go to the left, it goes down. So I put negative infinity. And then as x goes to the right, so I'd use infinity. What does the function do? It goes up. So that's exactly what this is saying. That on the left, it goes down. On the right, it goes up. Exactly what I have here. Okay. I'm going to actually probably copy this, paste it. Now, I might even go make that a little larger, where we can actually read it. Now this isn't true. On the left, it goes down. That part's true. But on the right, the function also goes down. So I need a negative sign in front of there. Okay, this is called end behavior. next. On the left, it goes down. Oh, on the left, it goes up. Get rid of that negative. On the right, the function goes down. So I hope you're kind of understanding this notation. And if I confused you on this part, type it in Desmos, see what it looks like. Okay, now we're going to identify whether each function graph is an odd or even degree and a positive or negative leading coefficient. So how do you know if it's odd or even degree? It's actually pretty simple. If it's doing opposite things, like that's going down and that's going up, it has to be odd. Odds always do opposites, they're oddballs. But if it does the same thing on both sides, like up and up, or down and down, we say even. Here, it's doing opposites, up and down. So the degree has to be odd. That's an odd O, but it'll be okay. Okay. Now, how do you know if the leading coefficient is negative or positive? You just look to see what's on the right. So if the right side goes up, that means positive. If it goes up, it means positive. And if it goes down, it means negative. Okay. And what do I mean by leading coefficient? Again, the 4 is leading coefficient. The -7 is the leading coefficient. The -2 is the leading coefficient. What do I mean by degree? It's the exponent, the highest exponent, 7, 6, 5. Okay. All right, so now we're going to talk about some other things. So you may recall, we're going to break these up. So we have x minus 1 squared. Okay, that's one factor. And we have x minus 1. That's another factor. Now what would the x-intercept be? That'd be x equals 1, because 1 minus 1 is 0. What's the x-intercept here? That should be a 3. X equals 3. Now the word multiplicity confuses kids, but all that means is how many times does it happen? Well, if it's to the second power, it happens twice. So I'd say, what if an m equals 2? You really should say multiplicity is 2, but just to save time, we're typing, I'm going to put m. And then here, how many times does x minus 3 happen? Well, remember, that's like a 1. So how many times does it happen? It only happens once. Graph at the x-axis. We're going to go look at box 1. Box 1. So it's either A or B. The graph crosses, goes through. Remember, that's when you have an odd multiplicity, or the graph touches the x-axis and bounces back up. That'd be even. So if it's an odd multiplicity, I put A. Even multiplicity, I put B. So that's even. I'd say B. And that's odd, I'd say A. Now, what's the degree? Here you have 2x squared. You have an x squared, you have an x. So that would be, if you add those degrees together, you have x, x, and x. So that's going to be a degree of 3. What's the leading coefficient? There's no number out here, so it's a 1. And because it's to the third power, and this number is positive, we're going to compare it to x to the third. Now, what's the end behavior? Well, if the leading coefficient is positive, which it is, it's going to open up on the right. And if it's degree odd, it does the opposite on the left. So I need to go down here, box 2, and look for the one that's saying negative infinity on the left, but positive infinity on the right. Let's see. So this is how you say it rises on the right, which it does. And then we said it falls on the left, it does. So I need rises on the right, falls on the left. I need C and F. Okay, so I'm going to put C and F. Now, maximum number of turning points, you just take your degree minus 1, and you get 2. That's the maximum number of turning points. All right, let's do another one. Our factors are x plus 2 squared. My other factor is x minus 3 squared. What are the x-intercepts? That'd be x equals -2. And for this would be x equals 3. How many times does that happen? Second power, multiplicity of 2. How many times does that happen? Multiplicity of 2. Now, graph at the x-axis. Remember, if it's even multiplicity, it makes a bounce. So the one that says a bounce, the graph touches the x, turns around, and goes back up. That'd be even, so that'd be a b. So I'll put a b there. So you put a b if it's even, a if it's odd. Now, what's the degree? If I take 2 plus 2, I get 4. What's my leading coefficient? My leading coefficient is right there. It's positive, 1/12. Graph comparison, we're doing the 4th power, and that's positive. Well, I guess we'll compare that to x squared. That'd be the best one, I guess. Now, what's the end behavior? Now, since the leading coefficient is positive, it goes up on the right. And since it's even, it's going to go up on the left. So we need the one that says rises on the left, rises on the right, rises on the left, rises on the right. That'd be C and D. C and D. Maximum number of turning points be 4 minus 1. That'd be 3. All right, one more. We have x. Remember, if it helps, that's x to the first. We have x minus 3. And we have x plus 2. And notice those are all to the first power. Whoa, 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 whoa. Why don't you go up to the exponent, huh? I don't know what's going on, but let's see. Clicking the exponent, doesn't like it. I'll do this. Maybe I knew it. We got x to the 1. We have x minus 3 to the 1. And we have x plus 2 to the 1. What's the solution for x to the 1? Remember, that's x equals 0. For x minus 3, solution would be x equals 3. And for x plus 2, solution is -2. Now remember, multiplicity, we would call that 1 because it happens one time. For 1, multiplicity 1, and that happens once. And when the multiplicity is odd, we would say A. The graph crosses the x-axis at the x-intercept. So I'd say A, or all multiplicity 1. Now what's the degree? 1 plus 1 plus 1 is 3. What's the leading coefficient? Well, there's no number here, so it must be a 1. I would compare this to x to the 3rd. Now, what's the end behavior? If the leading coefficient's positive, it opens up on the right. If this was negative, it opened down on the right. And because that's odd, whatever it did over here does the opposite. So we need the one that says down on the left, falls on the left, rises on the right. So falls on the left, F, rises on the right, C. So I'd say F and C. Now, the maximum number of turning points, I just take 3 minus 1. And I get 2, maximum number of turning points, 2. All right, so I have some problems out here for you to do. Identify the end behavior. Identify the end behavior. Notice you're going to circle one of those. State the end behavior. So whatever this says, you're going to copy one of those down here. Copy one of those down here for that one. Which one is this graph? What's the maximum number of turning points? How do you know the maximum number of turning points? Number of zeros. And then here, I'll do one of these for you. And I know it's kind of blurry, I'm sorry. But it says state the end behavior. So let me just do, let's do 26. So when I look at this, I know it's tempting to go look at this number, but 4 is not the highest exponent, 7 is. So I would look at this term. Okay, and because the 3 is positive, that means it goes up on the right. And then because the 7 is odd, but if it went to the up on the right, it's going to go down on the left. And so the way I would write that, I think I still have that in my text box, as x goes to the left, it goes down. And as x goes to the right, it goes up. So this one, actually, I didn't have to change anything. Okay, so this is what they're looking for, is this notation. Technically, this function's not called f of x, so I probably should change that to y. But most of the time, they're going to say f of x. Okay, so notice if I had accidentally looked at that first term, I would have been wrong. So that's all end behavior is, and we are going to talk about multiplicity some more. And I highly encourage, if you're on this, like, I don't understand a thing you just said, Mr. Parks, that you pull out your Desmos, you type that in. Sorry, I have to flip back and forth. So what would you tell someone? Look, it goes up. It goes up forever on the right, and it goes down on the left. So I need to say down on the left, up on the right. And that's exactly what I said. I said it went down on the left, up on the right. That's all it says. So good luck to you. Make sure you put everything in this notation. That's the kind of notation you will see on the test. I'm Mr. Parks. Hope you have a great day, and I'll see you later. Bye-bye.